In this video, I'm going to discuss about density of oceans. So density refers to the amount of mass per unit volume of substance. So it is measured in gram per cubic centimeter of volume and it is expressed as gram per centimeter cube. Density of pure distilled water is 1 gram per centimeter cube at the temperature of 4 degrees Celsius, whereas seawater carries dissolved substances like salt, so the density is slightly higher than the pure water. Density of seawater is 2 to 3% higher than the pure water, which is about 1.078 gram per centimeter cube at 4 degrees Celsius. Highest density is recorded at minus 1.3 degrees Celsius temperature because the density of seawater increases with decreasing temperature. Importance of density of ocean water are it determines the dynamics of water, so which is all about the movement of water, whether it is moving vertically or horizontally. So these movements are determined by the density of water. So then if the density is high, water sinks, so which causes vertical movement, whereas if its density is low, water floats and causes horizontal movement. If salinity of seas are more, then density is also more. So that's why people float on the surface of the sea water where the salinity is more. Here we can see the density structure of ocean. So this is the surface layer. So here density is less in the tropical region, tropical and equatorial region. We can see the density is less because if the temperature is high, density is less. So that's why here temperature is high in the tropics and the equatorial region. So here the density is low. Whereas here in this pycnocline layer, here density suddenly increases because here temperature decreases suddenly, so the density increases in this layer. And below this layer we can see that here density is more because here in the deep layer, so here density is more. At the same time, in this polar region, if we see in this region between 40 to 60 degree latitude, so here because it's cold here, so in this region density is high from the top layer to the bottom, so it's even from top to bottom, the temperature is less. So that's why in this cold region here density is even from the top to bottom, whereas in these two layers changes between 30 degree between 30 degree north to 30 degree south. We can see that some 30 degree north, say we can say it as 40 degrees. From 40 degree north to 40 degree south, we can see that there is a rapid change in density variation from top layer and the middle layer and the bottom layer. Controlling factors of density. Density is related to three factors. One is temperature, pressure and salinity. We know that if temperature is high, density will decrease. At the same time, if temperature is less, then density will increase. So thermal expansion and thermal contraction also plays a major role in controlling density. Pressure, because of the pressure effects, so it's a minor density changes can happen because the seawater less pressure effect is seawater, the pressure which is there in the seawater is exerted less, whereas in trenches it exerts a more pressure in the trenches because it's a closed region. Salinity, the addition of dissolved salts substances also increases the density. So temperature and density are inversely related. Temperature and density are inversely related. If higher temperature, then lower density, because the seawater expands, that causes thermal expansion of water. So volume is more here, so the density is going to decrease in higher temperature regions, so which is in tropics and subtropics and the equatorial region. Whereas lower temperature, because higher, it will cause higher density because seawater contraction of seawater, which is also known as thermal contraction. Because of that, volume is going to decrease, so the volume will decrease and the density will increase. Role of temperature in controlling density of seawater is more pronounced in tropics and subtropics. The importance of temperature decreases towards the pole. And because temperature of seawater below freezing point cannot increase the density of seawater, so when we see at 0 degrees Celsius, the water freezes. It forms into ice crystal. So here the liquid is formed into a solid. So here liquid water becomes a solid one. Because of that, this liquid is formed into a crystal kind of ice molecules. So here what happens? Here molecules do not move. So to come, they won't come closer. So in the solid ice. So what happens, ice floats on seawater, so the effect of temperature on seawater continues only up to 4 degrees Celsius, because the cooling and heating can occur up to 4 degrees Celsius. Beyond that, when the ice is freezing, so beyond that, here temperature doesn't play a major role in controlling density and latitudes. So here we can see in low, this is about this graph shows in low latitude. This graph we can see in high latitude how the density is changing. So here in this zone is a photic zone. Here the sunlight is received. So here, so in this zone we can see that density is somewhat less, but suddenly here in this zone there is no heat hints, because here it's a aphotic zone. It's a aphotic zone, so rapidly density increasing because here water is cold, and suddenly in the deep it is a constantly it is same. But this zone is called, this transition is zone is called pycnocline layer. And in this zone, whereas in high latitudes temperature is always less there, so it's a same there from top to bottom, density is same in the high latitude zone, whereas in low latitude zone it decreases, then suddenly increases, and it is constant in the deep layers. Pressure, so positively related to ocean water and density through its compressive effects. So pressure is directly proportional to density. Pressure is considered as a minor factor of seawater density because water is not much compressible, but effect of pressure of thick water mass on density is observed only in deep sea trenches. Because see, this is the trenches, so here this is the land mass is there, here land mass is there, here on the top water is there, so it's here so much of pressure is felt in the deep trenches, not in the ocean, because the ocean is an open one, so it can't have much compressive ability on it can't have much compression. But whereas in deep trenches it's a closed area, so that it can have a much pressure, we can feel much pressure in these closed regions. It is also just 5% higher than that of the sea surface area. Salinity is positively related to density. So dissolved salt in the seawater becomes more dense than pure water. At 4 degrees Celsius, density of pure water is 1 gram per centimeter cube. At the same time, at 4 degrees Celsius, density of seawater is, so which is carrying 35 per thousand. Salinity is 1.028 gram per centimeter cube. Temperature also affects salinity of seawater. In tropical ocean, temperature is high, so there is more evaporation, and high saline water overlies the low saline water. Density and salinity, when we compare density and salinity, here we know that in low latitude density is initially it is less, then it is increasing, and it is constant in the deep layers, whereas in high latitudes it's constant from the top to down, whereas salinity changes between latitudes. So here we can see that 0 to 4000 meter depth, but here we can see that here salinity is more. So here salinity is more and it is decreasing. So here salinity is more and it is decreasing inside under in the depth of the oceans, whereas here the salinity is less. So this is 44 in high latitudes, salinity is less because here melting water which is from the glaciers are melting, and which is joining the oceans. So here the salinity is less, whereas here in low latitudes, so here in temperature is high, the salinity is also high. So in between in these layers, so here 35.5 degrees Celsius, which is equator. So at the equator, because high temperature and evaporation is there, precipitation is taking place, so salinity is 35.5, whereas in tropics here rainfall is less, so that's why here salinity is more. But in equator precipitation is more, so more fresh water is added, so that's why salinity is less. Whereas in high latitudes melting water is added to the seas, so that's why salinity is less. But when in the deep, salinity is somewhat stable within the oceans. So density and temperature. Density, we know that so it is initially less, then it is increasing, and it is constant in the deep layers. But in high latitudes it's constant throughout the top to bottom. But temperature graph shows in low latitude temperature is high, initially high, So at the deep it decreases suddenly. This region is called thermocline layer, and suddenly it is constant in the deeper layer. In high latitudes, because here poor temperature, the insolation is less, so top to bottom the temperature is same. And density stratification of oceans, we can classify depending upon the density into three layers. So surface layer of low density, which is about 100 meter to 200 meters, which is also called photic zone, because here thermal expansion occurs. Because of thermal expansion, minimum density is there, because in low latitudes, so the volume expands, the volume of water expands in this region, whereas in polar region the minimum temperature is there. Excuse me. Because of that, contraction of water occurs. So because of that, the high density will be there. And here 2% of volume, if we see in the surface layer about 100 to 200 meters, we have 2% volume of water. Ocean is of surface layer, which is of low density, which is of surface layer 100 to 200 meters. We say it as 2% of volume water, which is of ocean water. Pycnocline layer, which is from 300 to 1000 meters, where sharp increase in density of seawater occurs, which is about 18% volume of ocean water. Whereas in deep layer, which is more than 1000 meters to bottom, here low temperature, because temperature is less there, and water contraction in poles, which leads to sinking of water, because here water sinks. The sinking water leads to flow of water, which is also called as water currents. And this region is more dense, and this volume is about 80% of the volume of ocean water. The surface layer is only 2%, and pycnocline layer is 18%, whereas deep layer has 80% volume of water. So deep layer has 80% of volume of water. So that's how, on the basis of density, the oceanic areas are classified into surface layer, pycnocline layer, and deep layer.